What do you see in the World Series this year?
I see
All right, boys, we're ready to roll whenever you're ready.
Houston.
Houston.
Houston and Dodgers.
God, Houston and the Dodgers. You love the Dodgers.
I like the Dodgers.
It's because your Dominican guys are down. No,
Yeah,
they
and
traded
it's
him to
blue.
San Diego, right?
Well, that Dominican guy? No.
Yeah.
But we have a long relationship with the Dodgers. My team in the DR.
No kidding. Well, welcome, everybody. In the studio with me this week is Melvin Perez, one of our senior fellows. Prior to his arrival at Construx 9 years ago, Melvin co-founded Cam Informatica, one of the largest software providers in the Dominican Republic, where he ran the technical division for 14 years. Melvin has a Master of Science degree in Software Engineering from Carnegie Mellon University, and he also completed PhD work at Rochester Institute of Technology. Among the many letters that follow his last name, Melvin is a CSDP, an SBC4, a CSM, a PSM, and a PSD. He has lectured extensively throughout the Americas and is a former IEEE Distinguished Lecturer for Latin America. He's bilingual in English and Spanish, but fortunately for me, he has decided to use English today. Welcome to the podcast, Melvin.
Thank you. Thank you for having me.
It's a long intro. Did I leave anything out?
It was very extensive, I would say. I'm now afraid.
You should calm down.
Sure.
It should be. This is a fun exercise. We're gonna have a good time talking about things today. One of the things I mentioned is that you lived in Rochester, New York. I lived in Rochester, New York. We both moved from the second rainiest city to the most rainy city, so we probably share that intelligence together, right?
Yeah.
Something like that.
It's an improvement, though.
Yeah, I think so. I definitely think so. It's been a good run. So today we're going to talk about developer testing, and when you talk about that, the software industry business has changed over the years. What does developer testing mean in today's context? What does it mean in today's environment?
I think the concept hasn't changed much. So we know that when we develop software, we're going to make mistakes at some point. Developers, we're going to make mistakes. And the point of developer testing is try to discover those defects as early as possible so that we can remove them when it is cheap and easy to do so.
Okay.
So I would say that what we have seen in the last 15 years is using some, I would say, design approaches that emphasize testing. They start with testing first, things like test-driven development, behavior-driven development, and but in terms of the testing techniques that we use and the techniques that we use for design test cases remain almost the same. The only thing that is changing right now is that we start writing those tests first to clarify our understanding of what we need to do before we write the code.
Okay.
But at the end of the day, it's about reducing that gap between defects that we're introducing and when those defects are found and removed.
Okay. So would you say that some of this emphasis has come from the emergence of agile practices as the predominant development practice?
Absolutely. TDD is one of the main practices that emerge from extreme programming. So I think the way that this has influenced software development has been mostly driven by that particular practice.
Okay. But so this is really about raising the level of quality and having the developers who maybe traditionally didn't play a big role in testing, moving them into the thinking about the whole product more holistically as opposed to just their segment of what the development practice looks like?
Yeah, so essentially is the way we call it is shifting to the left. So shifting some of the stuff that we tend to do toward the end of the project, try to do as early as possible. And testing is one of those things. It's validating what we understand the software needs to do, and it's not all we need in order to have quality. We also need to do code inspection that will essentially verify that software is not just doing what it's expected to do, but also that it's well designed, that we don't have, I would say, unmanaged complexity of dependency. So it's all about that, trying to do that as early as possible, shifting it to the left, making it part of in a sprint or iteration, depending on the process you use it.
Okay. So realistically, I guess anyone could probably use these. It doesn't matter whether you're an agile practitioner or you're doing sequential design. You still can think about this in that context, correct?
Absolutely. I would say that maybe what some people will not necessarily be willing to do is to change the way you're thinking when they're developing software. And what I mean by that is not necessarily everybody will be willing to do things in a test-driven development way. And it's something that at first people will reject to say, are you asking me to write tests before I write any single line of code?
Right.
That is like counterintuitive for them. But aside of that, you can apply all of these testing techniques and ensuring that you are testing as early as possible and the smaller chunks as possible. So if you're applying the I would say developer testing practices even after you write a code, you still doing what is expected and making sure you're not waiting too long for start testing. You write a function, you can right away write a test to verify that it's working, and you're testing after, but you are trying to catch those errors as early as possible. Is equally applicable to, I would say any approach that you use in terms of software development.
That's a good answer. I appreciate that. So let's talk about a recent client. Let's talk about something you've done recently. You just came back from Southern California. You visited a client down there, and that engagement was about developer testing. Why were they interested in that? What was the discussion initially with them?
I think the main goal for them was to improve quality. In general, there was different groups represented in the class, so it was not necessarily uniform. But in the majority of, I would say, the expectations were around how can we improve quality, how can we reduce defects, and by doing that, improve also productivity.
And this is a team that deals with telecommunications products, so there are a lot of complexity, a lot of different things, operating systems, hardware, different things like that.
Yeah, there were different groups represented. Some of them were working in kind of low-level code, and it will be embedded system
right.
on your cell phone, and some others were working on networking applications, so different flavors. But I think a common theme was the amount of complexity and interdependencies between those components that are building.
Okay. So I'm going to ask just a series of questions, some different things about the engagement itself and what you saw on the ground. When you do these engagements, I'm sure that you run into some common things that all teams seem to raise as an issue, right?
Mm-hmm.
What was give me something that was a common question you fielded during this session that you seem to hit all the time when you teach this class?
Yeah, that is easy to memorize because it's something that I see almost in every session. So the most common question usually is, how do I go about applying these techniques with the existing code that we have that is legacy, that it was not designed to be testable?
Mm-hmm.
And so it's a very common question, it's a legitimate question, and usually say, well, the only way you can do it, the short answer is go ahead and do it, right? But usually, along with that question, they will say, well, but we don't have time, we are not being recognized for testing, so how go about it? And, I said, essentially, this code that you have right now is the result of not applying these techniques and practices that we are discussing at this point.
Okay.
And it will stay the same if you don't do anything about it. So the only way that you can change your future with that code, or the future of other developers, is by start doing this now. So every opportunity for changing any line of code in that particular system or something that will touch that system, take that opportunity to write a test first to validate or to characterize the current behavior, and then go ahead and implement your changes, making sure you're not breaking the legacy code, because that's the deal with the legacy code, and we call it the legacy code dilemma, is that it's still there for a reason. It's because it's still valuable. Mm-hmm. It's running the business. So you don't want to break it. The problem is that sometimes you don't have an effective way to recognize when it is broken or when you're breaking it.
Right.
So having tests is a
Testing
good
first.
way for you to say, well, this is the current behavior. I'm going to make my change. This test still need to pass. If they are not passing, it seems like I made a mistake and I need to fix it.
Right.
And, you know, I tell this to all the developers. You don't need to ask for permission to do this. It's part of your professional duty to know that whatever you're implementing is doing the right thing. And I typically use an example, like if you have a contractor coming to your house and they're going to do, maybe they will remodel your bathroom, whatever, you would like to have, I would say, a reliable answer and say, do you fix the problem? And if they say, well, we think we've fixed the problem, you go ahead and try. You will
Sounds like
not-
how I make my repairs in my house.
Yeah, so.
Right, exactly.
So then you have to be, you know, professional about it and be able to demonstrate that your software is doing or your changes are implemented correctly. And having automated tests is a good way to do so.
So it's a way to kind of sense the brittleness of what you're doing. So if you write a test and something fails, you recognize that if you'd made that change, you'd have made maybe a bigger mess than just not doing anything directly. Right? You sort of instrument outside and test that way.
Correct. It's just basically a starting point, but there are other, I would say, tips that I share with them. Like, well, we know that it's not necessarily trivial every time, and if you're going to be making changes to your code, to that existing code, in order for you to write that first test, sometimes you need to change the code. And my advice is to minimize manual integration. So if you can use your tool, nowadays any modern IDE will have refactoring tools. So maybe what you need to do is to add a parameter or introduce an interface or something like that. So you can actually use those refactoring tools. It will make a lot of changes for you automatically.
Okay.
And that if you don't have the tool, then you're going to have, the concern will be, is this consistent? Did I make this change in all the places that I need to change it? The tool will take care of that.
Right.
So
that's a
you
way to kind of make
minimize-
things. That's a way to make things more testable
Yeah.
in some respects.
And, you know, to minimize the risk. So
Okay.
we're making the change to make it more testable so that you can either manipulate inputs or observe outputs. But when you do that change, what you're saying is, what we're doing is minimizing the risk of introducing a defect at that time.
Okay. So I have a question about workflow associated with making changes. If you have an organization that's supporting something in the field, right, and it's a big legacy application, and bugs come in, and you know, in a traditional agile environment, you move work to the teams, right? So how does a dev lead or a manager deal with that when you do have brittle code, and maybe the experience of the engineer is important to whether or not they should work on that problem? How do you when you're dealing with that in that environment, what would you advise a manager for a piece of code that's really kind of scary? You know, I would assume you would probably want to have a more senior engineer work on that that might have more experience with the code base. Is that an issue that you should consider when people are starting to do this kind of developer testing in related environments?
Sure. I would say that if you have a critical issue on some existing code, and you know, when you have somebody reporting, we have this problem and it's coming from the field, usually you have some urgency. So you don't have the luxury to say, well, let's go ahead and practice these things that you just started using or learning and have this new developer to go ahead and do it. So you have somebody waiting for that fix. So you would like to involve whoever is more knowledgeable about that piece of software, but take that opportunity to say, is there an opportunity here for us to apply the techniques that we just learned? And maybe pair this senior person with a new
Great
developer.
idea. Great idea.
So that they can basically start seeing, you know, this is possible. Sometimes they will need to ask for more time in order to fix the problem. But it's very likely, every time somebody report a problem about an area in your code, it's very likely they're going to keep reporting, you know, more problems on that area.
Right.
And the more you go about fixing without making, without having tests, the more liability you have on that
Yeah,
particular piece.
well, those are great answers,
Yeah.
and I tried to put you on the spot, but you did fine. So here's another question for you. In any engagement that you're involved in, there's always some moment during the class where there's particular teams that might be having a struggle with a particular concept. They're really, you try one way, they don't get it. You try another way, they don't get it. You try some other way, they still aren't getting it.
Yeah.
And you're thinking to yourself, how am I ever going to get past this point? How do I
Yeah.
get these guys to get this? So what's an example from this last environment, the engagement you did, some example of that you can share that was a
Yeah.
difficult thing to get across?
Yeah, those are those uncomfortable moments in which you look around and see, what can I do now? Maybe call for a break and then, go get some coffee, come back. And sometimes it's not, I would say most of the time, it's not a matter of the attendee. It's more about the approach you're using for explaining the concept, or maybe it is
Sure.
disconnected from the domain they're working on, or the complexity itself is not necessarily something easy to grasp. So in this particular session, something that had that effect was when I was explaining about modified condition decision coverage, MCDC.
Okay.
So this is something that I have on the material that is right now I use it optionally, because not every organization requires that level of coverage. Just to give you an example, this level of coverage is required when you're building a piece of software that maybe is going to be on an airplane, and if there is an error in that area, people
So high
could die.
reliability, safer
Yeah.
critical, mission
Safety critical. So
Okay.
it is demanded by,
Okay.
FAA. There are some standard for certain
So
pieces
medical
of code.
diagnostic equipment might
Medical
be that part.
diagnostic,
Okay.
yeah, as well.
All right.
But for this team, I decided to explain it because they're getting into developing components for, let's say, self-driving cars and stuff like that. So eventually, they were gonna
Sure,
need to
sure.
face this level
hope they
of,
do.
I would say, yeah, sure. And in order for me to kind of explain this, I have to walk through them, through an example and explain, try to find an easy way to kind of share some tips about how do you go about ensuring that level of coverage, explaining the difference, why it's important, because most of the things we read, when we read about, software that has good quality, some people will refer to, it has 80% coverage, but they don't say coverage of what. Usually they're referring to line coverage or statement coverage.
Okay.
Which is the weakest. So if you like to have a stronger, I would say, level of coverage, then you go for branch coverage, which is making sure that every decision in the program has taken both true and false. But that's not the strongest one, because sometimes you're going to have a decision that have multiple conditions. And just checking for true and false for the entire decision is not ensuring that every condition is evaluated, properly. So that's why we need to have condition and decision coverage.
Okay.
Now, the way you design the test cases may have an impact about, the effectiveness of those tests. So the modified condition decision coverage, what it does is to say, well, if you like to have full coverage, you can test everything. If you have
But that's expensive, right?
Yeah, that's expensive. You have 3 conditions, and you need to have 8 test cases. But modified decision coverage, what we'll do is say, well, we just want to make sure that we test every condition independently. We need to make sure that we test every condition in a way that we can demonstrate that it's that condition that is changing the outcome. So creating the test case, it'll take a little bit of, I would say, a more thoughtful process about coming up with those test cases. But it's really interesting, and I think it could be applicable also in other kind of contexts. It doesn't have to be safety critical. It could be something that could be, it could be, I would say, a business impact as
Right,
well. Like
right,
we may want to have
right.
that level of coverage. Yeah.
Are there tools that help you do this, or is a lot of this relatively manual?
I think that there are tools, and they are very expensive.
Okay.
Because, the people dealing with this level of coverage are people typically having good contracts. And obviously, whoever created a tool for that, it would say, well, I would charge you, equivalent to how much you're charging for those projects.
Wow.
So there are tools, but I would say that if you manage complexity, because that's the first step, try to minimize complexity so that you don't need to
In
invest
architecture or in
in the code internally.
Okay.
So when the way you make those decisions and how many conditions you're testing at the same time, that is a way for you to manage that complexity, such a way that you're dealing with only certain amount of complexity at any given point. So if you're dealing with maximum 3 conditions, then you can do it by hand. Now, if you have 16 conditions, then you have a bigger problem. But chances are that the first thing you need to do is to manage that complexity better, reduce it if you like, so that you can do it manually, so you don't need the tool. So that is something that could be actually tried before you move into using a tool.
Interesting.
Yeah.
When you're at different clients, how often do you run into to wanting to use this technique? I mean, do you bring it up all the time? Is it something that do you get that in the discovery conversation before you go to the client that says, oh, I'm going to probably need to pull this out when I'm there, and so I make room in the class to cover that topic?
Yeah, so essentially, before we go to a class, we call it pre-game call, in which we have an idea of what kind of software they're building, and based on that, I would sense if this would be relevant or not for them.
Okay.
And then during the conversation, sometimes people get bored and feel like, oh, I already know that, and say, okay, here's something you don't know for sure. And we can have that conversation. It's definitely an intelligent discussion, even if they're just going after branch coverage. After learning about modified condition decision coverage, they can design better test cases.
Okay.
Yeah.
Interesting. Yeah. So this really is something that you would use in these mission-critical environments where you really want to try and up your coverage. What is there a difference in those kinds of environments in terms of coverage? I mean, you mentioned an 80% figure as a relative figure. Is that more for commercial software that's non-critical, and so the more critical ones would have higher figures that they try and achieve, or how do you think about that in terms of a numeric or a measurement type of a situation?
I would say that the 80% number is across the industry, and
Okay.
it's kind of that generic number people use to refer to. Oh, that's good quality or good testing.
Okay.
But just from the top of my head, remembering some of the standards that require certain level of coverage, there will be certain area of the code. If you have, let's say, we are building an application for, let's say, an airline, and you have some code that will have to do with seat assignment. For that level of, for that type of code, they don't ask you to have MCDC coverage. They will say statement coverage, and it doesn't have to be 100%. But there will be some other code for which they will require, a higher level of coverage. And I think it is better to think that way, because it will make the organization to think about, where we should make that investment and try to get this level of coverage. It's kind of a risk-based approach.
Okay.
So you're making sure that you're making more investment in areas that are more
So this does
critical.
fall into sort of this definition of risk-based testing.
Correct.
In a
It's,
larger context.
correct.
Interesting. Okay. Well, I think we have time for one more question. We have one more topic I think we can explore. I think when we have technical service providers like yourself go out into the field, there are definitely times when you're with a class and there's a particular topic that gets people really energized. People gets like, wow, this is we need this. And people close their laptops, they put their phones down, they elbow the guy sleeping next to them and say, we need to pay attention to this guy when he's talking.
Were you in my
now,
class?
Right? Yeah, exactly, right? We need to, and they come back in from the break and they say, this is the part we all paid for to come and see. So in this particular engagement, when you were down in California, was there something that got people really excited that they really wanted to try? That they hadn't been doing it, you introduced the concept, and they all kind of all the lights went on and said, this is something that we want to do.
Yeah, definitely. So in this class, after we cover like the more, let's say, developer-oriented techniques like boundary value analysis, decision tables,
Now you got me.
design by
I'm asleep
contract.
now. Yeah.
So after we cover all that, we say,
Right.
well, if you're applying all of these techniques, it's very likely that you're going to catch most of the defects. But then I talk about something else, like what do you have if you have an environment in which you have different factors? It could be like the configuration of a system, in which you have different network protocols that you're going to support. You have different operating systems that you're going to support. You have different databases you're going to support. You have different UIs that you're going to support. And, at first you may think, well, all of these factors are involved, but they are not necessarily related. But sometimes they do. Sometimes, in this particular interface, you don't see this problem. When you go and use it in your cell phone, then you see a problem. Say, it's the same software behind this. Why is this not working? So combinatorial testing. So I would say that testing in general is a combinatorial problem. So you're always dealing with multiple variables. Every variable can take any number of possibilities.
It's almost intractable. It's a big problem.
Yeah,
Right.
so when you try to, let's say, have sufficient coverage in that environment, if you have, let's say, 5 variables and each variable can take 5 possibilities, we're talking about 125 test cases.
Right.
And if we're thinking in terms of physical configurations and you need to put together those 125 configuration to test the software, we're talking about a huge investment and something will take forever. So there is a technique that is called pairwise testing.
Okay.
Oh,
Tell me about
pairs. Yeah. So in this technique, what we do, and I think it's true for all the testing techniques, what we try to do is to take this high number of test cases that you need for full coverage and reduce it in a way that you have effective testing. It will not have the same level of coverage, but it's effective because you're testing the things that are likely.
So you're making an assumption of what would likely be a problem.
Correct.
Right. Is there some mathematical research that went into coming up with this methodology?
Yes, definitely. There is a research about how many factors are typically involved in most of the defects, and this has been done in medical devices, operating systems, different kind of systems. So they start collecting data about most of the defects, how many factors were involved. So the majority of the defects comes from one factor. In other words, if you're testing, applying all of those techniques like boundary value analysis, looking at one variable at a time, you're going to catch a significant number of errors. But then the next will be 2 factors. So if you test for up to 2 factors, you're going to catch around 80% of the defects.
Oh, wow. Okay.
So you rarely would have defects that was because the combination of 3 different, factors, or 4 or 5. So as you start moving on, you start seeing, well, this is kind of a, I would say,
Saturating.
yeah, I start getting down. So based on that research, what this technique does is to make sure that you're testing every pair.
Okay.
So if you take any 2 factors and you look at the possibility, you're going to make sure that there is a testing each combination between those 2 factors. And you can do it for any 2 factors that you have. So that reduces the number of test cases significantly. So, and one thing that I do kind of to open their eyes is to use an example. And for this, I use a tool. I would recommend to use a tool because, if not, then it's going to be very tedious to do.
Right.
So I have an example in which I have 9 variables, and each variable takes 3 possible values. So if you start multiplying this 3 by 3 9 times, this is like 20,000 test cases.
Right.
And then I run the tool and say,
Job
I want
security.
Yeah, sure. So I start basically saying, okay, let me generate the test cases according to all pairs.
Okay.
And from 20,000 test cases, we get down to 15 test cases. And that is like,
And that's when they all leaned in. That's when they all said, I like what this guy's saying.
And then start thinking about all those different dependencies and factors that are affecting their software. The software is, you can imagine a communication software. If it's something that's going to be living in your cell phone, how many factors are involved in order to
Sure.
maybe make a phone call or maybe go and check in your Facebook. So all of
Hypothetically
those,
speaking,
Yeah.
yes.
So they start thinking about, well, we have a lot of that, and how can we, if you like to have some confidence without investing, half the project in testing, this could be definitely valuable. So that was that moment, and they start basically taking notes and looking at the name of the tool. It's a freeware tool that is called Axe that they can go and download and use for this example. So that was that moment in the class.
Cool.
Yeah. Yeah.
So have you found a fair amount of clients that don't do this or don't know about this? Is this kind of maybe half of your people you talk to that haven't used that before?
I would say that in the majority of the classes, people don't know about pairwise testing.
Okay.
Readily, maybe one or two of the attendees will be familiar with it or have heard of it, especially if it's coming from a tester background. Given that this class is for developers, it is not surprising that they will not know about pairwise testing because
it's more of a traditional testing environment.
Correct.
So would you, because this reduces the number of tests that have to be written, would this be seen as something that you might not adopt in a safety critical or mission critical environment, or is this something you still might use or might apply in that? I
would still use it, essentially because it is based on evidence that this will catch 80% or more of the defects, right? And even in those environments, you are also constrained by time, budget. So you definitely would need to find a way how to reduce the number of test cases and still be effective. Now, one thing that I will do, given that this tool will generate, these are the combinations, maybe in those environments there is a particular combination that you want to test. So you may generate all of these 15 test cases, and then you start adding additional configuration that is very common. It would be, I would say, very critical for us to test the environment. If we have a problem, it could be a big deal. Then you can add additional test cases as you need
to bolster the amount you do.
Correct.
That's an interesting perspective. So you use a tool to do some of this, and then go back through with some other level of.
Yep.
Are there other tools you run to do the analysis to try and see how much coverage you have, and then sort of make a decision at that point whether you add additional manual tests? Or?
Yeah, definitely. You can, having, let's say, these 15 inputs, this combination that we have, we can create test cases. This is just generating the inputs. It's not generating the test case.
Right.
Because in order for it to be a test case, you need to know what is the expected output, and that's only you would know. So let's say we have those test cases, we execute those tests, and we can measure code coverage.
Okay.
And we can see if anything here, any area of the code that is not being tested according to any criteria, then we can add. But sometimes, you cannot replace the human being, right? So you cannot just apply this technique blindly or take those inputs generated by that tool and just apply it and feel like you got it all. You need to take some time to look at it and say, is there anything that we're missing? Even if you may have 100% code coverage, but code coverage is measuring how much of the code is being exercised, and not necessarily looking at some extraordinary condition or something that is not reflected in the code itself. So those are the moments that you may say, well, we have 100% coverage, we have these 15 test cases, but there is one combination that we know is very common and is not being used here. We know that these 5 factors, or these, I would say, instances of these 5 factors will happen very often. If we have a problem here, it's going to be a big problem. So you go ahead and say, we need to add that additional test case, and that's how you make it effective.
Excellent. Well, I think that's all the time we have today. Thank you, Melvin, for that discussion. I think those are really good topics, really interesting. This is certainly a really wide topic, lots of things to talk about. You're certainly passionate about this particular area, and so I thank you for your insight on this particular client's issues and some of the resolutions you had. It's really helpful, and I appreciate you sharing the knowledge.
Thank you very much. Thank you for having me.
So be sure to tune in next time for another edition of Construx Podcast. Until then, this has been Mark Griffin. Have a great next sprint. If you enjoyed this episode, feel free to give us a positive rating on Apple Podcasts, Spotify, Stitcher, or wherever you found us. If you have comments or would like to talk to one of our practitioners, or you have ideas for a future podcast, reach out via email using comments@construx.com. Again, that's comments@construx.com. We'd love to hear from you.